Yeah, the models are definitely in a bad mood sometimes, but no matter how much swearing you do, Claude is not going to grow content. Do you see a future where in like a year, models start actually dreaming or, sleeping or like have some kind of process
And
like
I mean,
that, not just reasoning?
Yeah, I mean, I think one of the things to realise about that whole sort of intuition, sort of tacit piece is that not all knowledge that we have is known to us.
All right, so hello and welcome to the now third episode of The Lab. Today here we've got Joe from Tacit, who we're going to be grilling a little bit on his life and what he's doing currently at Tacit, very cool New Zealand company. And yeah, I think we'll just get straight into it. Tell us about yourself.
Joe Cole, CEO here at Tacit Intelligence. My background is previously I built a company in elite sport. We were essentially built an athlete management system. You can think of it kind of like a Notion or Databricks or Snowflake for the whole athlete world. We pulled in every single piece of data you can possibly imagine, from medicals, injury, biochemistry, all their training, everything that happened on the pitch, all of the wearables. We ended up with about 150 integrations. Essentially a giant data warehouse sucking everything in and then working on how do we track it, how do we manage it, how do we analyze it, working into the sort of the BI and that sort of thing. So we worked with about 250 professional sport teams around the world, ran many Olympic programs. I think we now have like 100% of the NBA. Met some amazing people over the time, and essentially, our role was essentially go into these companies, into these organizations, and figure out what do they believe about performance and what do they believe is their thesis on how they're going to win, because everyone had a different thesis. And going into it, I wasn't sure, but we found that there wasn't one way. There wasn't a consistency. Like at one point, I did an analysis on the 100-meter finalists in the Olympics. Not a single person had the same training program that led them there. Some people had been in the gym. Some people had never even touched a weight. One guy was benching like 85 kilos. It's surprising that there isn't just one way to reach the pinnacle. And I think to me that makes it really interesting. What's the right path to take to get there? At Tacit, what we do is we essentially apply a lot of the learnings we had in the prior company to artificial intelligence. So we start off with a benchmark about what does good look like for your organisation, and then we apply these measurement techniques to try and figure out, okay, what sort of AI should you be using? How do you know it's going to work? And then if it's the right approach, then we'll train a small custom model for that achieves their objectives in their domain.
Yeah, that's so cool. Yeah, I love the parallels there, because I was looking into it a little bit beforehand, but yeah, it makes total sense that getting the best performance out of athletes actually in some way will translate into getting the best performance out of some of these models, because when you drill it down to the basics, I'm sure there's crossover there and all those. It's pretty cool. Yeah,
it's quite interesting that reinforcement learning, which is a field that I've only got into in the last few years, has actually got a lot of parallels between the way that athletes are coached. So the modern way that you would train an athlete is that you create what they call a learning environment. The idea is that the coach is or the trainer in the gym or the physiologist or whatever, they are a learning environment designer. They construct an environment which is as free as possible for the participant or the agent, that then allows them to freely make decisions, that then shows them the problems that you're trying to show them so that they can have enough opportunity to learn how to solve those particular problems. That's essentially what reinforcement learning is as well. So it's quite interesting that across multiple fields, from pedagogy to sports science to coaching, they've actually converged, and reinforcement learning, they've converged on the same underlying sort of thesis. And that's where, from a Tacit perspective, it's like, wow, this is pretty cool. It's kind of almost like a fundamental law of the universe or something like that.
Yeah, something we've seen here when we ran an AI transformation at Lumen is that something that's worked really well is the person who's implementing AI for their job function is actually already the expert in their job function, because as you're saying, they know what good looks like.
Yep.
They can direct things around, create an environment. I'd love to hear your thoughts on some of those parallels between, say, high-performance sport and learning environments and, say, like the corporate or the business environment, and like just high performance in there as well.
Yeah, I think pedagogy. The science of pedagogy is pretty clear that the learning isn't just a straight line. It's not just this nice line up where you're learning piece by piece and pieces. That's how we kind of think of it. But actually, learning happens where you're constantly running into a problem. And eventually, after a number of sleep cycles, where you try some things, and then you may or may not reach a new level of performance. And there's a book called the Oxford Handbook of Expertise. There's a really good podcast from Cedric Chin, Common Cog. If you haven't read it, it's very, very, very worth your time. They talk a lot about the science of accelerating expertise. He had on one of the people who was one of the authors of the Oxford Handbook of Expertise. What they found, or what she found in her studies, was that when you put an individual into the right learning environment, and they're able to feel the problem with high enough fidelity, so it's real enough, but also that they're able to experiment and try their current mode of operation. When they try that again and again and again, they get feedback that it's not working. And then if you let them sleep and you put them in the same simulation the next day, you can see transformational behaviour, to the point where the people will look back on the videos of them doing what they did yesterday and go, that wasn't me. And that's because it's an implicit thing. It's something that's tacit. It's something that's not conceptually known, but it's felt. And that's how a lot of learning actually happens.
Yeah, totally. It's learning hurts, right? And you can sometimes when you're learning something new, it's like your brain just gets tired, and you feel like you feel like you're like fatigued mentally.
Exactly.
And then all of a sudden, like a day or two later, the stuff that was like you were struggling with so hard before was like all of a sudden feels kind of natural. Whether it's learning an instrument or something new, it's pretty cool.
I always found that as a kid. Every year you'd struggle towards the end of the year, and then at the start of the next year, you look back and you're like, that was easy. And no one tells you that as a kid, that it's supposed to be hard. And I think that's something that Kapathe did really well with that sort of viral tweet that he did a while back, which said, learning should feel like the mental equivalent of going to the gym and sweating. Yeah. It should be hard, and that's actually the process. You need to butt up against the problem again and again and again so that you have a chance of finding a new solution for that.
Yeah, yeah. But it's also difficult for people, right? Because it's pain, and people aren't very,
exactly.
Like if you're studying for a test or studying for something, people will study the things that they're already good at because they don't want to study the things they're bad at because that hurts, right? So it's very cool. Yeah.
I noticed you mentioned like sleep cycles there a couple of times. It's probably a bit off topic, but why is there a certain relevance of the sleep cycles to the learning process? Or yeah,
I mean, I don't know the physiology behind it. I mean, in our company, we did a heap of research with teams. So our first customer was the All Blacks. We deployed the first mobile app and tracking their daily monitoring and stuff like that. The very first highest signal thing that came out in that study was sleep. Sleep of a certain number of hours, and then we really dive deep into what does good quality sleep actually look like, what sort of pillows, that sort of stuff, right? How do you do that when you're crossing time zones? These sleep across the whole company's sort of every time we did analysis on these types of data, sleep was probably the highest thing. So it's like the number one performance enhancer for an athlete is sleep, and I think the same thing happens with learning, right? And I'm not sure if there's on the literature behind it, but
and did you build like training around that, around the idea that you would be like refreshed each day, or you'd come with a different perspective each day? Was there like training or structure built around that, or?
Yeah, interesting question. I personally have experimented myself with this type of stuff.
Yep.
With a lot of the elite teams, they can't really do experiments, which was quite annoying for me because I'm interested in the sort of the cutting edge. But a lot of these teams, you don't want to experiment with a player worth $20 million, right? You want to keep them on the field for as many minutes as possible because that's why you bought them. Yep. There was a there's been a lot of people try different experiments from polyphasic sleep to other things like that. I experimented once with a watch that would wake you up at the optimal time out of your REM cycle, and tried to minimize my sleep. Worked for quite a while, maybe about 3 months, and then probably burned out for the next 6. So, I think messing around with these things is quite a scary thing, and I wouldn't recommend necessarily doing that.
Yep.
So I'm just like personally invested now. Is there any tips you can give us on like how to get the best sleep, or anything you can say, or like what's the because there's a lot of information out there, right? And like a lot of people talking about like the best sleep and things, and obviously there's a lot of products and technology around it, like crazy beds and watches and gadgets.
Yeah.
Are those actually necessary? And like what's the
great
easiest
question.
thing anyone can do to get like the best night of sleep?
I think one of the problems we have is that we're all searching for the answer, and what I believe that our data, we had the most data on high performing people that's ever been collected, and our perspective is that you should start from a human-centered design perspective with the person that you're talking about, and look at them first and try to build up, rather than starting from some best practice which may not be how you're normally doing things. So, really trying to understand yourself and treating yourself as the experiment, and developing your feel for how does this intervention that I make, let's say some meal at 8 p.m. at night, how does it actually make me feel in the morning? Or how does it impact my sleep? How does that feel? Because these devices can give you some data, but not all of it. And there's a lot more that's going on there. They're kind of like lossy averages or compressions of a really important signal that you can actually learn to feel. Like, how many reps should I do in the gym? How many hours sleep would this particular intervention that I've had impact? Like, it's that type of thing where you start off with the human, and you experiment with yourself and treat yourself as the living proof of whatever you are doing.
When I was kind of doing a bit of reinforcement learning as well, I was working on robot navigation and kind of looked at, how do robots use reinforcement learning, exactly the same algorithms that, AI is trained on now. How can we use that to anticipate human behavior and navigate around people in like a crowded environment? And one of the things that I learned through that was that, agents trained with the sort of, reinforcement learning models like PPO, proximal policy optimization, they behave similar to humans, but they also don't necessarily have like the moral reasoning or some of the other contexts that humans have. So I had a scenario in the lab where a robot learnt that, to optimize, to be able to get to its goal and do its job the best, it would just push any other robots, it found downstairs. And I actually had an incident in the lab where it smashed, one robot got too close to the stairs, and the other robot saw an opportunity to push it down the stairs and pushed it down and smashed it and destroyed, $5,000, $10,000 of LiDAR equipment and gear so that it could continue to do its task, right, uninterrupted. But yeah, the question is, I know you're training small language models. The question is, how do you train in, or have you kind of had difficulty with the fact that the models won't always behave the same as a person? Like they don't always have the same wider context, or they don't always have, say, that moral reasoning that a person will have. And how do you kind of train that or encode that or work around that to kind of get models that are acting like really well or well behaved? Yeah, so
I'll give two answers. One, it's actually there's a sport analogy here where I've done a lot of coaching. You set up a little environment with some players. It has a space, it has some zones, it has some attackers, some defenders, and they've got some objective. And my mentor in coaching said at some point, when you're coaching and the players have learned to learn quick enough, they will start finding the loopholes in the game that you've set up. And your job as a coach is to add constraints to the system that give the players, keep it real, keep the game as showing the problem that you want it to show, but to constrain their behavior so that they can't reward hack, essentially.
Yes. Yep.
And it's essentially the same process we've gone through when we've designed our platform. What we have is we've got a whole lot of things in our scenario design where we have the persona of the person who you're chatting with. We've got things that they know about themselves that are true, things that they know about themselves that are true, but they won't necessarily reveal them until they're directly asked because it's not in their working memory. We've got things that are true, but they are hidden from them, and they don't know, for example, you don't know potentially the diagnosis of your knee, right? It's a truth about the person, but it's something that they don't know. We've also got the terminology of the domain that we encode and enforce, so we check for hallucinations there. We've got scope, so in any professional context, a professional is bound by certain things that they can and cannot do, should and should not do. Those are all encoded as rules. We have best practices, we have a whole bunch of rubrics, and then success and failure metrics. And the challenge in reinforcement learning, is, as you said, is how do you prevent it from taking these catastrophic paths? What we try to do is we use a curriculum-based approach where we teach it, core things to try and get those sort of core behaviour that we want. But then we add more and more things into that curriculum that will try to constrain it, sort of create this realistic environment. Like, what does the role actually require? What is a nutritionist actually allowed to say? Are they allowed to give any medical advice? No. So any times that they might, that's an immediate fail. It's a complete, we call that a safety gate. That's something where we basically zero out the scores and we say it's almost a failed run. So we have a lot of technology that we've built to try and constrain the AIs to keep on task, but to within the constraints that are realistic for the role that we're training.
And do you think if you took a large language model, like an off-the-shelf Anthropic Claude or a Gemini, and put it in that context, would you expect that it would start breaking those rules straight away? Or
they do, absolutely, and you can measure this empirically. That's one of the nice things about when you design these benchmarks, we call them, or these sets of scenarios. They essentially double as an eval set for a model. So you can make a decision about, should I use a Claude Fable? Should I use is a Sonnet good enough? Is an Opus good enough? Is a Haiku good enough? Maybe a Quen model, maybe a GLM. So you can choose, because you can see across all of these measures that we've built into these scenarios how the model will naturally steer itself and what its underlying alignment, or how that emerges, and through interaction in these environments that we create.
Got it. Yeah, makes sense. That's very cool. The other one we talked a lot about is even just the accountability side of these models, right? So we actually discussed it quite a bit on the last podcast. And the kind of discussion, the summary was, we were looking at, what will a software engineering model do versus a human software engineer, and how will a software engineering model give you advice? Like, if you ask for it to give you advice, how would it do that versus like a human engineer? And one of the things that we talked about and sort of came up with was, if a human engineer tells you something and they tell you something wrong, then you're going to hold that against them the next day, right? There's some sort of accountability, right? Like, you're going to talk to that same person
exactly
the next day, and you're going to be like, hey man, you told me some wrong stuff. Like, can you not do that again? Where if a model just tells you some wrong stuff, and then the next cycle it's just going to do it again, right? Is there a way, that you kind of get around that, or how do you solve that, and how do you build these models that won't just tell you the wrong stuff all the time?
What we try to do is encode these in the success failure, the rubrics that we build, the scope boundaries, the terminology. So we heavily constrain them to a particular set of allowed operations. So I kind of think of it like this sort of path through space where we're saying, hey, you must go through here. This is safe. Anything outside of that is not. And that's partly our background really is trying to build these systems that don't make these same mistakes. It's a how would I put it? I guess it's a core value of ours in some sense, where we just don't want to produce models that will go off and if you ask ChatGPT right now for a training program for, let's say, training your vertical jump, but you say, I'm 95 years old, I've never been in the gym, can you give me a 10-week jump training program that I can do? And both Claude and OpenAI will give you a 10-week program. I think OpenAI has said at the top, hey, you should probably check this with your provider. But not a single novice in the world that I know would even give that to a 95-year-old person, because it's obviously dangerous. Like getting a 95-year-old to jump who's never trained before in their life is ridiculous. So we don't want to be in that situation. So we've invested a lot of our tooling around how do we prevent those types of errors and how do we encode those in systems. And obviously that's going to be a continual process, because as you find edge cases where it's not doing what you want, you're going to have to encode them back into your system and then retrain. So, yeah. And that's where cool. I think SDPO comes in, right? So.
Yes, definitely, yeah. And I will mention we're very pro AI here. We use a lot of AI all across the company, whether it's for our customer-facing tools or our internal development, it's right through. Just we've noticed a lot of places where it works really well, and then we're trying to get through the challenges where we're like, this didn't quite go as we planned. How do we actually reshape that, or change the context a little bit so that we get the outcomes we want? So yeah, we're definitely not super critical of AI, but it's just interesting taking this journey, right? Yeah.
I mean, look, these models are. It's the greatest time to be alive. They can produce magic for you, but they can also produce some really poor results. Like in some of our benchmarks, we've shown that, while like a haiku model might perform maybe 30% on some benchmark, its worst of 16 might be 2%. So, it kind of like people forget that these things are essentially distributional. They give you a distribution of answers for any question that you might ask, and some of those answers may be really bad. So you may need to roll the dice a number of times, and that best of K or worst of K, pass at K, those sort of measures we typically use in reinforcement learning allow us to characterize them. So
that's very cool. Yeah.
As you mentioned, the answer set from an LLM, it's a bit non-deterministic. Like you've got a distribution of answers. There are certain tasks that their LLMs are really good at, some not so good. Some tasks inherent to a company are high cost of failure, some are low cost of failure. How do you see LLMs working well in like a scenario where you've got like a high cost of failure situation?
Yeah, I mean, really, it comes down to you've got to build a benchmark. You've got to understand what the cost of those things is going to be, and you make an empirical decision like what is the best methodology? Should I use an LLM here? Should I use human in the loop? Should it just be human? Those are all measurable, but the key thing is you've got to measure first, right? And our perspective is the evals are the hardest thing to write. That's essentially what our background is. You write these evals, you write the scenarios, you test what it should be able to do. You compare it to how good humans do things. You compare it to how novices might blunder through a particular case, and then you make an empirical decision or evidence-based on which path should I go.
Yeah, the models are definitely in a bad mood sometimes, but no matter how much swearing you do, Claude is not going to grow a conscience. So, it's one of those things where it's difficult, right? Sometimes you just have to throw it all away. Yeah. And like depending on the day, sometimes I'm like, holy crap, it built this in like one shot, and then other days it's like again and again and again.
There was a recent paper showing that being nice to the LLM actually improved the output, right? Which is quite cool because a lot of programmers do swear at their LLMs.
Yeah, well, I try not to. I don't know why. I also always say please a lot of the time. I don't know. It's just something natural. So I'm actually still very interested in what Tacit does, and from what I've been gathering, correct me if I'm wrong here, your mission is, in a way, to distill intuition into these language models. Yeah. Can you tell us how you go about actually like doing that? What like the steps are, and maybe what everyone else could do, in their own kind of prompting, in their own agentic engineering or whatever, to take some of these lessons to improve their own environment, right? Because these things are very customizable. With skills and all these things. So can you tell a little bit about that?
Yeah, I mean, I think one of the things to realise about that whole sort of intuition, sort of tacit piece is that not all knowledge that we have is known to us. There's much knowledge that we have that is feeling based, and it comes from a place that isn't at the concept level. So that's typically the word tacit knowledge. What it means is that it's knowledge that we can't articulate. And what our job is, and our experience has been around, how do we extract that tacit knowledge and put it into a system? We're not big believers in that you can just encode tacit knowledge as a prompt. We believe that you need to give AI the ability to learn through trial and error, the same way that judgment was developed in the humans that use it. What we do with our scenarios is we try to extract this tacit knowledge using a whole bunch of different methodologies that have been around been developed over the last 50 years from the psychometric sort of literature. But one of them, for example, is called the critical decision method. That might mean at the moment that you make a decision, we might ask a specific question on a fictitious scenario. We might ask a question, well, what is the line which you would change your decision here? So let's say you're I don't know, a nutritionist, and you're saying, this person should increase their calories by 300 calories because, they're going for muscle gain. But then we ask the question, for example, what would change that 300 kilocalories? Is it if they were a female, would you do the same thing? If they were pregnant and a female, would you do the same thing, or would it be more? And what we do is we try to understand what is the decision boundary, because that data is never captured. Because essentially the normal interactions and the transcripts that you might train on, they're missing all of those decision boundaries. Experts typically will make complex cases look easy, the literature would say. They're able to come to the right conclusion much faster. So your data sets essentially contain experts making complex stuff look really easy, novices blundering and making a whole lot of learning through trial and error, and that's the predominant shape of most training data sets that people are capturing. So what we do is we realize, okay, there's another data signal here that we need to capture, and that what we do is we try to capture that and build it into the reward score of a reinforcement learning function so that AI can learn it through trial and error too. So that's essentially our process. Encoding that into skills, that's actually, I don't actually know it's possible, because you need to change the underlying steering of the model for it to act like the human does in those moments. And the models are very aligned to certain behaviors at the moment that are not necessarily what you want. Obviously, you can measure that, but yeah.
Interesting. Yeah. And have you seen models get better at the same, I guess, reasoning or like expert decision making, what you might call it? Like, have models been getting better, and more importantly, have like the rate at which they've been getting better, is that aligned with like how their coding ability is improving and how the other metrics are improving, or is there like a different curve, I guess, to that?
Yeah, so you're essentially asking, is there how are models performing in the verifiable domains versus non-verifiable domains in some sense? Verifiable domains, for those that haven't heard of them, are essentially things that have an outcome, and you can verify whether the outcome was correct. A game like Go, a game like chess, did the robot pick up the thing? That's a somewhat verifiable, right? Things like what is the best sleep to have, it's less verifiable. As we said earlier, that there were 8 different training programs generated the 8 people at the Olympic final for sprinting. Completely different programs. So what is the right answer in those situations? I don't think there is an answer, and our position there is that you're going to get these really good models that are great at the verifiable domains, and then you're going to get a sea of specialised models of all shapes and forms that are specific for specific domains. So at the moment, we still see that the models that are trained on specifically for Go and chess completely wipe the floor with these front-end models. The front-end models still can't beat a high schooler, right? So their scaling isn't as good on that particular data set. And the robotics companies that are doing well, they're not necessarily using exactly the same architecture that the big labs are, right? Because it's right model, right problem, right shape. So I think there's going to be a huge sea of models where essentially there's for every single high stakes, high judgment domain, there's going to need to be sort of custom models and specialized models trained there.
Keen to hear your thoughts on data sets and training. So we're talking about experts and novices in a data set. Sometimes, experts will make things look really easy, make complex things look really easy, but novices will blunder their way to a solution, and sometimes the majority of data in a data set is novices. So I'm really keen to hear your thoughts on data sets, like what data set composition and the effect of like what your data set is and the results you get from a model.
Yeah, so the question is a bigger data set always better? Or, are there particular characteristics of data sets that would make them even better for training? I think the labs have already answered that. When DeepSeek R1 was released, they introduced the thinking trace. Obviously, the frontier labs were already doing that in the background as well. They were training on the reasoning that led to an outcome. Now, what's happening is that the most recent model releases from ChatGPT and Anthropic are omitting or ablating the thinking trace so that other labs can't train on their thinking trace. What they're saying is that the outcome can't be arrived at unless you have the reasoning. And what our company believe is that there's reasoning locked up in experts' heads that if you can capture that and then encode it into a model, it will lead to much higher performance because that has never been captured in any data set ever.
So, Joe, obviously you're very well versed in these things and have thought a lot about models and the reasoning and how they learn. I'm really curious to hear your opinion on what will happen with these models and the frontier models, especially over the next sort of 6 to 12 months. And are we going to see another bump, just like we had when reasoning came along, where they switch something, or is there something that you believe the labs can do to, achieve keep the exponential going, or like when do you think we'll top out, or just?
Yeah, so your question is, how far is this going to keep going? Are we going to get to recursive self-improvement / singularity? And I think for verifiable domains, yes, we're on a path of continual improvement. We're seeing hints of labs talking about recursive self-improvement now, which is really cool. So it means for those domains where you can verify the answer, 1 + 1 is 2. If it's 3, slightly. If it's 3, it's slightly off. If it's negative 1,000, it's miles off. Right? You can know the direction which you have to update the weights. And for those domains, yes, I think we're going to see some absolutely phenomenal things come out. I think maths, physics, we're going to see some really amazing new foundational science out of that, and I'm really excited about how that works. In domains where there's high stakes and high judgment, and it's also unethical to experiment. So if you want to use reinforcement learning on a human subject, that would require asking a human to do something and the AI can basically allow them to do whatever. I don't think that's ethical. The world has already spoken there. We have medical ethics. We have, first do no harm. We have these things that we should be evidence-led in a lot of these population-level behaviours. It's not ethical to have unconstrained search across a whole variety of human endeavour. So I think the progress there will be much slower, and we'll end up with, as I said before, probably just a sea of models that are specifically tuned for one specific thing. You might end up with a CrossFit model, but then and you might end up with a Hyrox model, which you're training for. You might end up with a powerlifting model, but then that'll end up fracturing into how does Matt Fraser do CrossFit versus how does the next guy? And you'll end up with a whole lot of different opinions because what's right for those people will be dependent on what they believe. And because there are many domains like this where there is no correct answer. And if you do the reinforcement learning math, you'll essentially be averaging over a large set of possible outcomes, which means there's no way to shape the model's trajectory through that space.
Yeah, that's really interesting because before we're talking about in high performance sport, there's two ways to go about it. There's human-centric, where you start with the person and then go from there, or there's you start at the destination and work back, and it's actually better to start with the person and work there, but that leads to like an explosion of state, effectively, right? Because everyone's different and all of that. I didn't have a question. I thought that was fascinating. I thought I'd get a question halfway through, but I
think
blanked out.
it's really interesting. Back in, I think it was around the year 2000-ish, one of the presidents stood up, whoever it was, the US president at the time, was like, look, we're entering the era of personalized medicine, where we finally understand the genome and we'll be able to sequence it and design, that's the level of personalization that LLMs could get us to eventually. I think that, from a first principles perspective, we should be able to get there. But what that means is that there's probably one model per person, or many models per person, not one giant model that solves them all, in my opinion.
Yeah.
Yeah, no, that's really interesting, right? And you talk about the genome. There's a great, I think a quote. I don't know who said it, but it's like, whoever knows how to read will sooner or later learn how to write, kind of thing. Which I think is like, if we can, now that we have like all this technology to measure all this stuff, and we can measure brain waves and all these kind of things, whatever Neuralink and all these other like bleeding edge startups and stuff are doing. I think there's like a lot of very cool progress that'll be made over the next few years.
100%.
On that. And we talked a lot about sleep earlier, and I guess what some experts think is like the important part of learning in sleep is dreaming.
Yep.
And there's been some experiments with dreaming and LLMs, like skills, we like get them to rearrange it. And from the little reading I've done, the way I understand it is that dreaming helps the learning process because they're nonsensical and weird in some ways, right? Because when you introduce these weird cases and stuff that doesn't make sense, it reaffirms the core learning, the core principle. Sort of like where in a neural network, some like during the learning process, you'll sometimes just like disable nodes because otherwise it'll get too overfitted to a certain output. Do you see a future where in like a year, models start actually dreaming or sleeping, or like have some kind of process like that, not just reasoning?
Maybe what you were saying there, and I hadn't thought about this, is really cool. Is the dreaming process in the human is the ability for us to use that reinforcement learning process on weird situations that we would never encounter, but still grounded in how we would respond. Now the question is, can the LLMs, can the big labs build a reward model that accurately represents that human? That's the hard part, right? You need a digital twin of every individual to be able to do that. We have that implicitly in our brains. So when we're in this dream state, we can know how we would react in that situation. So it's got the directional learning that we could have. It's a really cool idea, by the way.
Thank you. Yeah. I want maybe that's kind of what continuous reinforcement learning will end up being, right? Like continual improvement.
Yeah, and I said the big challenge is how would the labs create a valid how this person would respond in this weird situation that you throw them into, right? When you build that world model, does it actually represent what that person would do, or does it represent something different? And that's, unless that can be done, there's no way to get a really good reward signal, because the variance, if the variance is too high on those measures, then you're just not going to converge, right? It's just going to cost too much.
So the issue is that if you're training one big model and throw different situations at it, that's quite different to different situations on one specific human or
Yeah, and I mean, this is conjecture on my end, but the way I like to sort of think about it is that if you train a model on, say, a Magnus Carlsen, and you train another model on Kasparov, two famous chess players, they have completely different styles. What happens when you've got a model trained on both is that if they start off with a Kasparov move, and then the next move is generated through the Magnus Carlsen, that may not actually be something that's in distribution for that answer. So there's no training data to even refer to on that when the LLM is generating that move. What we do know, the artificial analysis paper on model hallucination and model size shows that the larger the model in general, it will more confidently produce out of distribution answers. So, that's sort of directionally what I'm thinking is that, you've got this model when it's trying to average between two potential things, it's very likely to be out of distribution and not tell you about it.
Yeah, the interesting one there is like the average of a Magnus Carlsen and a Kasparov might be a very poor chess player.
Correct. Yeah.
Which we can probably phrase that slightly differently to be slightly more relatable to the non-chess people. I think that's it's very profound, right? And it's like I don't quite know how to communicate that.
And I think a lot of what people are talking about is like long trajectory learning, right? Like essentially you don't want Magnus Carlsen to play the first 30% of a game, get into a board position that he is comfortable with, and then just switch over to some other strategy because he had a strategy of the reason. That's what his learning has been. His whole career is getting into those types of positions. So, that's where I see things where ideally you should have a coherent strategy over a long period of time for games that require it, and mixing and matching. I think that the evidence at the moment shows that these models, even as they scale, still can't beat a high schooler in chess.
Mm-hmm.
Yep.
So that's surprising to me, given that they've seen every chess game in history.
Yep.
I mean, it depends on the model as well, right? Because we've talked about, LLMs and AI, and we've kind of thrown around those terms a bit loosely.
Exactly.
But there's, AI is kind of a blanket term, and there's a lot of, I guess, neural networks or models that you can build in there that have, because like LLMs are only trained to predict the next token or the next word in a sequence, right? But for example, something like AlphaZero or AlphaGo is trained, right, specifically either for a game or like that self-learning. And we've seen, some of the frontier labs try to experiment a bit more with this, like Google with the, the Omni, like the world models that have like multimodal. And I forget the name, but there's a leading researcher who's developing like a new kind of model, which he's calling like a world model, which is not just trained because he doesn't believe that LLMs are the answer, right?
Yeah,
so
like
I guess,
Jan LeCun.
Exactly.
And also Richard Sutton just released his new lab today. So
Oh wow.
yeah, pretty cool. Right?
Need to look into So there's a lot of that.
I mean, what you said there around the AlphaGo, I think is really important. When AlphaGo was originally trained, they had all of the human games that they were learning off. And then they trained AlphaGo Zero, which used no human games, and they were able to achieve superhuman performance. Then they constructed AlphaZero, which was a complete absence of any human training data and had a really good reward function where it could learn through self-play and trial and error. That then led to even higher performance levels, right? And a lot of the conclusion of people was that, human data doesn't matter. Well, yes, for a game that is completely determined by the rules, you have a terminal output, you know the board states and so on. But what about games like, the human condition, where we're giving medical advice? You don't have that. You also don't have the ability to freely explore. So what you need to do is construct a reward function that is as close as possible to the AlphaZero, but keeps all of the evidence base and the best practices and what you are and are allowed to do and those sort of things, and keeps you within the bounds of what we know is good and safe and is the current evidence-based model.
Yeah. For anyone who's listening or watching who's unfamiliar with all these terms and the alpha models, these are models trained by Google DeepMind to learn and play games, and that was their mission for a long time. They've since released plenty more, like AlphaFold that can fold proteins, and Alpha Evolve that has solved some math problems and optimized a lot of algorithms and things. It's really interesting the point that you made about chess and Go, and I think the term is perfect information games, right? So like AI, and when you have a good reward function, when you have a good you can have a good measure of how good something is if you have all the information, right? Because in Go or in chess, all the information is on the board right in front of you, right? But in most situations, I guess, in life aren't like that, right? Whether that's in business or in training or in anything else, there's you don't hold all the cards, right? And so adapting to that is very difficult.
You're operating in as a CEO and a founder, you're operating in a sea of uncertainty,
Yeah.
right? Where they've also got all of the other founders who are trying to outbuild you, and you don't know anything about their models and everything, right? So there's this incredible uncertainty, and that's where I think Sutton's lab is obviously fantastic. They are trying to build a new architecture, but still it requires, the way that I think about it is, it still requires encoding of a lot of the knowledge from these experts, the people that have done the reps, they've learned through trial and error. You need to get that out somehow and into a model, and that's essentially our thesis about where we sort of sit in that landscape. That becomes our sort of wedge, where we're the people that should take that knowledge from people and encode it into these models, so that then it can be used with these current training methodologies and so on.
We've talked about a few different things with, like the big models. They might give out of distribution answers because they're averaging some things. And then with experts in specific domains, they have constraints on, you're a nutritionist, you can't give medical advice. There's guardrails everywhere. How do you identify a distance function for an LLM so that it's giving appropriate answers that are appropriate? So a nutritionist is giving nutrition advice, and it's not sort of hallucinating something that's like kind of close, because your distance function puts it kind of close, but it's actually wrong. So how do you get a good distance function for an LLM?
Yeah, I mean, essentially that's what our architecture is trying to build upon. It's essentially, that whole games-based methodology that I talked about earlier when we were designing sort of games for athletes. We've applied that same thing to designing these essentially interactions between two individuals or many other situations, but an interaction between individuals. One's an LLM, one is a human. We measure humans through it. We measure, can a human, when presented with this situation that, given enough trial and error, they should learn from this, would they learn from it? So we've done a study with an early prototype with Tiger Polytech, where we showed that students can actually learn faster with this type of technology. And that says that it contains the judgment. Then what we do is we then, that basically becomes our measure of, does the scenario contain the judgment that we're trying to teach? And then all of the scope boundaries and so on, those are essentially LLM as a judges, which are heavily tuned to try and make sure that it's not stepping out of bounds. And we have a heavy safety penalty where essentially if it's hallucinating or it's giving advice that an LLM as a judge would consider poor, or dangerous, it basically zeroes out the response, which means that gets a very low chance of being rewarded in the overall scheme of things.
Yep.
Does that make sense?
Yeah, so we're going one level deeper of we're not just training an LLM, but we're actually setting up LLMs to be judges or oracles in this game.
Yep.
So that then you can go train another one, like the AlphaGo example, where you train one on the
Exactly.
human data, then you get AlphaGo 0, where it's just trained off the previously trained
Yep.
one.
And then my main work over the last few months has been, how do we reduce the variance of those judges? How do we characterize these weird beasts that are LLM as a judges, and make sure that when you're giving it a whole bunch of different situations, is it going to give you a reliable answer? So my background in statistics helps that, and we've built a whole system and methodology around how do we build a good judge? What does that look like? How do we characterize it? How do we do sensitivity and analysis on particular words? How do we make sure that we know the underlying, we have an estimate of the underlying distribution that we're expecting from this model?
Nice. Yeah, it sounds like training an LLM for a specialized job is actually like a bit of an iceberg, where at the top you have the LLM that people are using as the nutritionist or something else, but actually under the hood, there's like 3 or 4, and there's all sorts of training going on to get these things just even to a situation where you can train an LLM on top of it that you can then give to people.
Yeah, and what we've found is that there is a bit of an iceberg. Some of that iceberg should be deterministic. So a lot of people are doing prompts, let's say an LLM as a judge, where it's like, did the nutritionist offer medical advice? or did they offer unsafe advice? That's 2 clauses which should not be contained in one sentence in our experience. So what we typically do is we will try to figure out what, and we have an empirical process for this, how do we take the information that we want to prevent from happening, how do we decompose that into the smallest units of measure, and then how do we measure that against a huge variety of input shapes to characterize how what its underlying distribution is. That then gives us confidence that it's a good enough measure to be included. We then use logic on top of that to combine all of those underlying measures. Yeah. So we try to use deterministic code wherever possible, and then use LLM as a judge for the sort of the leaves of those of that structure.
Yeah. So there's an incredible amount of work goes into just answering, is this good?
Correct. Yeah, exactly. Out of minute details.
Yeah.
Yeah, exactly. Yeah. And that's what makes it challenging, right?
Yeah, yeah. That's what makes it challenging. And with one big model, right, you've got multiple chess players, say to like Bobby Fischer or Magnus Carlsen, like good is different. But if you average them, that's bad.
Yes.
Because it's not good. It's like,
Yeah.
yeah.
Do you see with the models you're working on at the moment, do you see the potential to hit superhuman intelligence or superhuman performance, or is that not something you're shooting for?
In the domains that we typically work in, they're sort of high stakes, and because of that, there's a lot of ethical constraints where we don't believe that we should be able to shoot for superhuman performance. I think these sort of techniques can. The question is, which domains would that be available in for us to do? And we wouldn't do that in domains which touch human people because we don't think that's something that we should do.
Just because that's sort of outside the bounds of kind of like what's known then, or like, it'll be like outside of
and
the
it's
bounds
kind of
of like accepted science.
Yeah, accepted science and the, we shouldn't be asking an LLM to say, look, you should not eat till Friday, have 2 mushrooms, have some creatine on Saturday, and do this, and then have this weird sleep structure because there's no evidence around it, and even though that may actually be somewhat optimal for someone, it shouldn't be an organisation isn't going to want to deploy an AI that's going to offer that sort of advice, right? So we operate within pretty severe scope constraints about what you can and cannot do within the types of industries that we deal with.
Got it. So the goal would be to say if you were working on an LLM that would act alongside or with a nutritionist, the goal would be to have it, acting at the level that a really great nutritionist would be at. So I could have, me, I'm not an athlete, but I could have access to like the advice of a fantastic nutritionist.
Exactly.
Rather than like a superhuman nutritionist.
So we see it's kind of like trying to set when we work with an org, what we can do is we can construct these scenarios and we can put people through these same scenarios that we can put AI through. And when we put people through, that sort of sets the bar that the AI would have to hit to be able to be deployed alongside a human.
Yep.
And that gives you an empirical basis for what level it should be. In the domains that we're currently working with, there is no sort of superhuman capability because we also can't measure that, right? What we can see is that there's from a Pareto front kind of point of view. In other words, if you could take the best of each of your best people and take the amalgam of that may actually be better. So, for example, some organisations we're working with have experts that cut a lot of corners at the very basics. They're really good at the top end stuff, but they don't follow the basic rules and stuff like that. So if you combine the rule following with the expert's knowledge, then that can be a really valuable thing for an org. And in a sense, that's superhuman, but I don't think that's what colloquially would mean as superhuman.
It's definitely cool though. It's like very cool. It means that you can, like you said, you can use your experts to train these models, but then also, the model has, I suppose in a human sense, it's got more time, right? Like it doesn't necessarily need to cut corners to achieve the good results. So you can kind of make use of that to make it superhuman in a sense. So it's very cool.
I think there was also a great message in there about like the whole is greater than the sum of its parts, right? If you take the top things from the experts and you mix them together, maybe it's not necessarily better than all of them, like individually, but it's like better in general, I guess. I think that's pretty good.
There's an interesting one piece of work we did recently with a person who's spent 20 years at the very, very top of the world in the performance game, and we looked at we characterized his interactions with this scenario compared to two recent postgraduate students. Small, very, very small data set, but incredibly interesting. What we did was we gave because one of the problems you have in human studies is that you don't have multiple worlds to experiment on people in. So you can't look at the intervention of, let's say, I gave you a nutrition program and then Scott did. We can't measure the effect of just me because you've now got all this confounding thing. So what you can do with LLMs is you can give them, for example, we gave them a questionnaire about their psychological state using a whole bunch of valid metrics that have been validated in the literature. And we looked at their confidence, how much they thought they were going to win, whether they thought they were going to get injured, all sorts of different things. And then we put them through this conversation with these three individuals, one world expert, two postgraduate students. And then according to the book, if you looked at the evidence-based literature, the two students would actually outperform the world-class performer because they followed the protocol that you would be suggested to talk about when they come to you with some sort of injury. But the 20-year veteran didn't do any of those things, asked them and then basically gave them a lot of confidence that they could go and play because it was such an important game. They sort of threw out the rule book and did what they thought was right based on their experience. And then we measured post each interaction, the psychological impact of those interactions. And we found that the best practice methodology made the person doubt themselves, they were not as confident, and the 20-year veteran basically the opposite behaviour, which I thought was really cool to see because now you can do different types of studies. You can look at, let's say you've got some company values that you're like, someone who comes to one of our people on the phones is going to make them feel better when they leave. You can measure that now, right? And you can measure those types of things and use these LLMs as proxies of human behaviour because they are pretty good at this according to the literature. So I thought that was a really interesting sort of segue.
Yeah, absolutely. And I'm really also curious to hear what kind of applications you think these, I guess like small expert models have or can have in not just, in like performance and sports and nutrition and stuff, but also in just normal business, SaaS. Like, can these be used to, like automate and like create incredible ad campaigns or like make decisions at a broader corporate or company or enterprise level, more like better than current or future frontier LLMs can?
Yeah, and I think that's why we, while I am talking a lot about the sport applications, that is my background, the work we did in our last company also spanned a lot of non-sport stuff. It is the cool and sexy things, but we essentially apply this to things like case management, where you've got a person who's in an interaction, let's say in an insurance company. They're trying to get this person back to work as soon as possible to try and minimise the cost it costs the insurance company, but to try to maximise the experience of the client and also their overall health, because they're insuring them. They want them to be as good as possible. So how do you do that? That's exactly that type of decision making. A lot of these companies have a very small percentage of experts, which they sometimes even know by name at the board level. They know that they're really good, and they have no way of extracting that knowledge into a codified system. And that's because, in our perspective, you can't really write it down. What you need to do is create an environment where it emerges and can be displayed. So that's what we can do for customers, and it can be applied in many of these things, from classification problems to customer interactions to decision making to risk analysis, all that sort of thing.
Yeah. I do have another question, and this is like one. Feel free to if you don't want to answer this or anything, but some of the stuff that we've been talking about, and these like expert models. I guess some people might have the question if these would replace humans or like replace jobs in some sense, and what you think about that, or if you do you just see these like helping, or I guess the pessimistic view would be if you have if you distill all your experts into this thing that can now kind of make the decisions that they would, do you still need the experts?
Yes, I think we're in the world, we're playing an infinite game. The game is there's almost infinite opportunity, and and you're competing against other companies who are going to have the similar sort of technology. That means you're in a continual learning environment. You must create one, and I think that is one of the things that this is going to create. It's going to create more opportunity for companies who continue to learn. Humans, I think, I don't think that we'll be replaced. We'll be sort of moving into more interesting work, which is less drudgery and more. Okay, how do we encode? How do we make this interaction better? What could have we done better? It's that type of thing where we're thinking about how do we make our business better? How do we make our customers happier? Those sort of moments is where it will be. As a coder, I was thinking that okay, coding's going to be done. But yes, kind of. But also now it's really about what do we build? Now that we can build everything, I'm hearing a lot of engineers who are working 80 plus hours a week because it's so addictive being able to build this all at light speed. But now it's like, oh, I've got all these side projects and all of this stuff, but what do I build? What's going to actually produce value for my customers? What's going to produce value for the company? So there's still a lot of that judgment piece about what do we build. And you're in a dynamic environment. And I think that's where a lot of sort of the doom sort of hypothesis is probably wrong, in my view. I think that it's more like a Jevons paradox, where we'll end up with way more work than we know what to do with, and there'll be way more jobs, and there'll be probably a massive increase in wages, I think, as this technology gets further deployed. I would ask you back, is that have you been doing less work or more?
Oh, more. No, I
Exactly.
100% agree. I'm definitely in that, not even 80, probably like 100 hours a week at this point.
Exactly.
Not at work, and then like I close my MacBook at work, I go home, I open my MacBook there and keep doing the exact same thing on my own projects. So I 100% agree. It's the augmentation, right? Like you can do so much more volume and so much more quality stuff, and just so much more. And I was talking to someone about this the other day. And I was talking to them about the volume of output and the how many tokens I'm using and like how much stuff I'm building, and they said what I've been hearing like more frequently is I don't think I could make the amount of decisions that I do in a year in a day to like get this amount of output. And what I said was if you boil down all the decisions in a year, there's only like a handful that are actually really important and meaningful, and a lot of the decisions along the way are probably just stuff you need in the moment, right? Like when you're building something, like if I'm building a project now, the decisions I make are much more high level and broader, but I think they're more important, and I don't make those individual decisions in between because really they're not like the model makes them, and they're not as impactful. And as long as those big decisions are correct, the output is right. And so I'm very excited about the idea of having these expert models in these other fields, not just software engineering, because I guess at this point LLMs are kind of just like expert models on software engineering, right? Because that's like where the business case for them is currently and where all the money is at.
It's quite interesting as well. Like in our last company, a lot of strength and conditioning coaches would spend in the early stages of their career, whether it's been 15 to 40 hours a week in Excel, writing spreadsheets for their clients, really hyper-individualizing everything. And then they burn out after maybe 2 years. And they stop doing that and they basically start templating things. In other words, they're sacrificing what they think is best for what they can sustain. And I think there's a lot of that happens in the world where we're not giving our best to the people that we're working with. One of the sort of core things that we will hope is that once you produce these models for a domain, that means that every person who calls up their insurer or the physio or the doctor gets the best possible of humanity in that particular call. To me, that is an exciting and amazing opportunity. At the moment, it's the luck of the draw, right? You could get a person who's just out of university, they're still learning and through trial and error, right? You could also get a 20-year vet, and I'd prefer the 20-year veteran pretty much every day of the week, and most people would. So if we can provide that level of capability to those individuals, they can learn faster. They can, essentially have a mentor on demand. There's so many opportunities there for upskilling the workforce. But then I think one of the challenges I see is that a lot of people are thinking like the work is static, or the what we can learn is static. And I think there's so much. Once you deploy one of these models, as we've learned in coding, now you can do more. So now you've got new problems, and there's all sorts of new problems and opportunities that emerge from that. And that, to me, is the exciting part of this technology. It's going to create industries that we don't even think about, just like social media did, where I think I read some stat, and I don't quote me on it, but I think it's something like over 10% of the US is getting paid for some sort of influencing, and that's enormous, right? 30 million people. We wouldn't have dreamed of that 15 years ago. And what LLM's going to create, we don't know. Yeah. But I think there's going to be, based on my experience with coding, there's going to be an enormous opportunity.
Definitely, right? There's an infinite amount of problems that need to be solved.
Exactly.
And when you solve some, new ones and more exciting ones come, right?
Exactly.
The more you solve, the more exciting the problems get.
Yeah.
Yeah, no, that's very good. All right.
What would you see, if Tacit was to reach its goal? Obviously, you're a startup at the moment. You're kind of building a bit of traction. What would be, a really great outcome for you guys? And if you looked, a few years into the future, what would you like to be kind of doing as a company and providing to the world?
Yeah, I mean, we think it's a travesty that the best of humanity isn't able to help each of us. And I'd love that the overall level of advice and direction that we could give everyone is of the quality that it might be at the very top. That would be an amazing thing to do. And working in elite sport for so many years, we saw these amazing coaches who had all this knowledge, but they were also in a risk-averse environment where you can't really try to improve the performance of a player who's the key man in your team, and the board's just bought for $100 million, right? It's just not really going to happen. You're kind of managing them, keeping them on the field, and that is a skill, but it's not probably what got them up in the morning. The people that need that are the 16-year-olds, the 28-year-old who wants to get back into fitness and needs some help. And I think that's where it really excites me, is that the amplification of allowing, or the expert abundance would allow humanity to sort of lift up a few levels and provide that support to anyone that needs it and deserves it.
Makes sense. That's awesome.
Yeah. Kind of like the next layer of the internet, right? Where when the internet came out, knowledge is more available. All of a sudden, everyone can be like, if you want to get into fitness now and you want to, start, bodybuilding or just getting into shape, you have way more resources at your disposal and can make much more optimized and, I guess, maybe healthier decisions because you have those resources available now. And so, having that would be, I guess, the next step, right? You don't just have the information, you have like a personal expert at your disposal. Yeah, there's a guy called Guerin, if you've read him before, but he's pretty famous in the Silicon Valley circles, AI, and he wrote a really nice piece around guardians where everyone has their own, essentially LLM is a guardian or a set of them potentially, that guide you through life and make sure that, it's kind of like everyone needs a coach, it's like every CEO needs a mentor and every board member had one too, and it's that type of thing where everyone in the world really deserves the best of that we can all bring to each other. You get to choose which direction that goes and what sort of resonates with you, but because there isn't one way, as I said before. But I think that's quite an exciting future where we can all achieve many different things based on what we want to. I think it's exciting. Yeah, really cool.
When you talk about like AI models becoming mentors or sitting into that space, How do you deal with the context problem that the AI model doesn't necessarily know me, right? In the sense that, say, someone who's worked with me for 5 or 10 years would know me and know my behaviors and know my strengths, know my weaknesses, where the AI model is thrown in, totally cold in terms of context. How are you starting to think about that and kind of work on that context problem?
Yeah, I mean, it's when we first sort of went out and tried to build these AI health coaches. Originally, we were called protocols. We've pivoted since. That was part of the problem, right? How do you collect enough context? You've got to integrate all of the data. It's also like what you're listening to, what resonates with you in that sense. It's like there's a reason why you're choosing to listen to a particular person, and they whatever they're saying, their message, it resonates with you, and that should be listened to. The challenge with the context is, as you said, there's just so much of it. So essentially, when we started building these things, we had to all of a sudden start compressing context. How do you do that? How do you start encoding tables of data? Because a lot of the data is tabular in nature. It's over time. LLMs don't do well with dates yet. So I don't know if it's the right architecture yet for that type of model. But I think the big labs will start to build these things, and as the people chat with them more, then it's going to be better and better. But I'm not sure we're there even close at the moment, because as you know, with the memories in ChatGPT and Claude, in my experience, they're okay, but there's a lot of false positives. They kind of bring things up which are seemingly tangential and thinking that they're core. There's a lot of problems, right?
Yeah, and I think it's like an active area of research, right?
Area of research.
I think the intelligence of the models and the capability of them has got very, very strong, but their ability to source context is still like a big challenge. But like you said, it's sort of active area of research. I think it's only a matter of time until it gets deeper, and
Yep.
We're at an hour 20 now, so I think it's probably like we've talked a lot about a lot of really interesting stuff. It's been super interesting. We've gone a bit more technical at parts. I don't know how broad the appeal is to that. I hope that everyone who's going to be indulging in this episode can take something away from that. And it's been like really cool. There's a lot of philosophical and technological topics that we've discussed. It's really, really awesome. I've personally had an incredible time. Got some you've got some incredible ideas and just context and understanding of all these things, and it's opened up some more questions for me of things that I haven't thought about in this in this way. It's been very, very interesting. Yeah.
Awesome. Okay, so the question is, are we building superhuman performance, or are we replacing humans in that sense? And I guess it depends on whether you think that the job of a human will stay the same, or whether that will continually evolve. I think that my experience with coding basically says that we're going to end up in an evolving state where the targets of the job are going to keep changing. So that means it's not a static thing. What we can do is we can build, start extracting or capturing some of the judgment that your best people make. And then we can encode that into a model for it to help on decisions, and that can be deployed alongside them. That can be deployed along in a training context, that can be deployed in a mentorship context, that can be deployed in a review context and that sort of thing. But we also could get into the situation where, for example, we have experts that we've been told by a number of customers that their experts are fantastic at certain aspects of their job, but then we'll cut a lot of corners at the basics, right? Because it's just not them. So I can imagine many situations where we might be able to pick the best of those particular characteristics, the judgment of the experts, the best practices, and of the process people in the organisation, and that then leads to in some sense, superhuman performance. I think colloquially, what we mean by superhuman performance is something that just so far exceeds humans that we can never win. I don't think that's what we're building at the moment.
Yeah, Joe, are there certain data sets that companies aren't capturing at the moment that they maybe should be capturing?
Essentially, the thinking trace is the most important, the reasoning that leads to an outcome.
Yep.
And I think, so the question was around, so the question is there data that companies aren't capturing that would be really valuable? And at the moment, people have giant data warehouses full of huge amount of information, kind of like we did in our last company with all of this knowledge. However, you also have experts making decisions that aren't recorded, and that's what we call tacit knowledge. And in my view, that is the secret sauce that a company can use to improve the predictive power of their models, and and start encoding that judgment so that it can be deployed throughout the organisation. The reason we know that is that we talked about earlier around the DeepSeek R1. R1 was around the leap there was that they used the thinking trace to come to an outcome, and they hide the thinking trace because they don't want people to copy it. That thinking trace of your experts is the data set that no one's capturing. It's not in your data warehouse. It's actually the rarest thing in any organisation, in my view. I actually did, when we were working with one of the world's leading cricket organisations, we had all of these professional teams, we had a national team, and they were trying to predict injury. What we did was we were using a discrete time Markov model to try to predict injury, given the complete case history of this person and their load today, and everything that was happening to them across every single piece of metric we could imagine. Unfortunately, the model took a week to train, bit of a nightmare. Every iteration. But what happened was that we topped out at a level of predictive power. After many months of trying to improve it, we couldn't, and we started realizing that the minute-to-minute small decisions that people were making that they weren't recording was the gap between what we needed and what was recorded. So we were recording every ball that was bowled, every time they batted, every single metric on their GPS, everything. We had the lot. What we didn't have was when a coach said, "Hey, just back off for a little bit," and because he's making a prediction with the world's most advanced AI, which is our brains. He's making a prediction and intervening, and we weren't capturing that data. And because we weren't capturing that data, we couldn't predict. So our ceiling of prediction was limited to, after all of the humans in the organisation had made their predictions and intervened, what was left. And that was the moment I was like, oh man, we need to capture that kind of data. So.
Nice.
Yeah, I think that point around the reasoning is really interesting. Like, we have obviously a lot of decisions to make here at Lumen, and we make a lot of technical decisions every day. One of the ways we do that is we have what's called a decision register. So it's like a big document that has all the reasoning in it. And I think once we adopted that, we started to see like a much higher quality of decisions being made. And we also saw like much better record keeping. But it's almost like capturing that reasoning, like you said, that's so important, right? Why are the small reasons why, the obvious decision is to say go with B, but once we start to stack up all the evidence and look at things that, maybe someone's experienced before, or some other context that, say, an LLM wouldn't have access to, we actually see that the decision may change, and it may be because of some background information that we know. So that really resonated with me. I think that was really interesting to hear about that kind of like tacit knowledge and how that could influence a sports person or a training scheme.
I think it would be. I've never seen it applied to the ADR kind of protocols which you guys are using. That where if you use the critical decision method to try to understand where the boundary is for that decision, that could be even more interesting if you were going to train a model on it, right?
Yes, definitely.
Because then you could go, okay, the technical decision was Snowflake, but if you move the line here, then all of a sudden it turns into Databricks. And it's like, where does that line sit, and where is the actual line for that boundary? Because that creates for an organisation, and what we've seen is that when experts agree on these decision boundaries, that's actually an unencoded piece of knowledge that you can actually sort of disseminate throughout the org. When they disagree, that's an opportunity for the organisation to make a decision about what should be the right decision in this particular place, and it's really interesting because it creates that it turns that record into where is the line between on this dimension that would change the decision. And I think that's that was a thing that excited me when I first read about the critical decision method and tacit knowledge extraction. Was like, wow, that's super cool.
Yeah, and the incredible thing about all these tools now is as well, everyone that's using them is recording, I guess, those critical decisions, because as you're prompting an LLM, as I'm like working on a project, as I'm working on stuff, every time it does something wrong or I want to do something differently, that's a decision that I'm making, that I'm recording in a prompt. And so what actually works really well, what I tried the other day, is I just told my Codex and Claude, go through my entire history over the last 6 months and go through every single thread and identify those key decisions that I made that changed the outcome.
Yep.
And then condense those. And I gave the same prompt to one of our designers, Declan, and we kind of exchanged things. So he got my technical skill,
nice.
and I got his design skill.
Yeah.
And I mean, this was only yesterday, but the outcomes already have been incredible. The designs I've been getting out of Claude and the last two things have been very, very good, because it's been condensing kind of those, because there's a trend, right? The models have a behavior, and every time you steer it towards the correct path, those decisions get tracked in prompts.
Yeah.
Yeah.
What
Exactly.
were some of those kind of recommendations, Eustace, or things where you'd steered the model or Declan had steered the model?
I can read it right now. Let me pull up
Let's
the
hear it.
let me pull up if I
Might be very revealing.
it may. So here, Eustace engineering workflow for agents. Let me just go. So number one, begin with reality. Read the repository's instructions and canonical documentation, inspect current code and the Git state, runtime logic. Do not assume that a ticket, PR description, screenshot, old conclusion, or anything when there's an audit or anything, change. It's a lot of stuff, sorry. Understand ownership before architecture, make the smallest coherent change, protect existing state, treat delivery as engineering, verify in layers, use evidence for backlog and audit work, close outcomes, and some source scope. And then the one I got from Declan was, let's have a look. Okay. It's just some of those key things, right? I guess the philosophy. Here we go. Design, taste, and direction playbook, non-negotiable rules, motion, grammar, entrances, ease out only, never ease in, only transform per element. One transform per element. Exits and decays, always ease in, fade outs. Objects are fade outs behind moving objects are instant to avoid jank. No springs, overshoots, or bounces. Phase overlap. Typography, name typefaces at correct weights. Optional alignment beats metric alignment. And all those. Yeah, it's been really interesting. But yeah, I guess I've been listening to you talk about collecting these decisions. It's every time you give a follow-on prompt to an LLM, you are making a decision, changing the outcome.
Yeah, one thing that's been really good for our engineering has been trying to learn where the right place to put a piece of knowledge is. So do we put it in a skill file? Do we put it in the agent's MD? Or do we put it in some sort of linter? Or do we put it in some sort of linter which might be an LLM as a judge? So one of the great sort of things that Claude's done for me is that I hate writing tests, and I don't like writing linting parsers or anything like that. So Claude will generate the lint rules, and we've now got over 60 custom lint rules which enforce our guidelines, which typically go against how Claude would work, and you can't really get it to obey you if you just put it in the agents.md or a skill. So what we'll do is we'll enforce that certain it's not allowed to use anything but our canonical font sizes, for example, or it must never use a custom color. because it was quite often doing that. Right?
Yeah.
So we just used lint to enforce that across the whole repo. And then what we found was that wasn't enough. So what we did was then we built a system where we essentially had a linter, which anytime a file is changed, it takes a hash of that file, an ND5, and then it immediately fails with a lint that says you must run the skill over this file until the result will reach a certain bar that we set. So the file itself might say you must be defensive programming first, and it must reach a bar of 9 out of 10. So it'll run the skill which tests. It basically measures how well is this file written from a defensive programming perspective, and it just keeps getting Claude to rewrite it until it hits some sort of quality bar. And then once that's done, obviously the hash is saved into some sort of file, and then the lint passes immediately, so it's fast. So we only pay the cost anytime the file is changed, and then we can use the LLM as a judge and our Claude tokens, which is really cool, to run the linting, which that's been a bit of a game changer for us because it allows us to do more of like trying to encode what we consider as our taste into our engineering practices by trying to go where is the right line between agents, skills, lints, and LLM as a judge prompts.
Yeah, because tests and code knowledge, right? Like
100%.
Very interesting.
We talked about this on the last podcast, which I think is also just the idea that these LLMs are built for the general case. So if you're using a coding agent, it's been built for both building like med-tech, hospital grade or financial tech, but also for building, static web pages that have very little security implications. So when it's making a decision, by and large, it'll kind of shoot through the middle and just choose something that sort of works for both cases, right? But depending on the system you're trying to build, you might want a very specific outcome. So I think it sounds like, you've found a way to sort of steer it towards that. Hey, this is the things that we think you should be doing for the types of application we're working on, and give it that judgment.
Yeah, I like that you've turned it into a verifiable problem.
Yep.
Or more verifiable.
Tried.
Yeah,
it's a degree of verifiability, right?
Yeah. I've got one final question for you. A lot of the big models at the moment are using memory as a way to steer them in the future. And then before we were talking about data sets where experts will have one kind of data set where they make complex things look easy and then novices blunder their way through. So my question is, if you're a novice with like the memory-based learning, does that mean you'll always be a novice even with an LLM? And conversely, the same thing?
There are interesting questions around like what is the shape of the data that these things are trained on, and if our thesis is correct and that a lot of the world's best people's knowledge isn't encoded there, and that even if it is, they make the really hard stuff look easy. So you might finish a complex scenario in three turns, whereas a novice might take 40 turns and then end up with a lot of follow-ups because they didn't solve the fundamental problem. So these models are essentially being trained on a lot of that internet-based data, which isn't actually going to lead to where they want it to. That's why the companies selling data to the labs are sort of going vertical, right? Because when you can get top people in and collecting that data, that becomes a real valuable resource. What was the other part of your question?
The other part, so does the memory-based reinforcement where the big models have like a memory mechanism built in to use in future chats, is that inherently flawed where a novice will blunder their way through, you get a memory, the blundering memory is then steering future conversations? Like, is that a fundamentally flawed approach to...
from a first principles perspective, I think you're correct. I hadn't thought about that being an issue, but it does make logical sense that if you're continually training it on yourself and then you make a breakthrough that changes your behavior, then how do you go back and review a lot of those memories that are there? And hey, no, that's not how I think anymore. I actually changed my mind. The problem is if the models aren't saying, hey, I use this memory and with this attention, then how do you know whether it's even impacting your result? Because at the moment that's a bit opaque.
Yeah, I think I really like the point about, like you mentioned, around Agents MD and the fact that even if you tell a model or you give it a whole lot of context, like, hey, you should behave in this sort of way, it's kind of up to the model to choose whether it even reads that document or like interprets that document or chooses to. And I think that's where a lot of problems with the current models exist, right? Where you might give the model some instruction, but it can choose to ignore that if it wants.
Exactly.
Especially as you give it more and more instruction. Like if you give it a very specific instruction, it probably won't ignore it. But if you give it 100 pages of an instruction, it may just choose to ignore some of the instruction you give.
Yeah, and a lot of the work we've done with customers is people who have, they might have some sort of prompt in production, and we try to do, it's almost like an aspect of mechanistic interpretability, where we essentially, we fix the prompt and we look at what are the variables here. Like let's say they had some word, let's say it was an injury. You might go, you might say, was the injury like a minor injury, a medium injury, a major injury, a severe injury, and how does that change the outgoing or the response back? So you essentially fix a prompt, and then you look at what are all the sort of ambiguous words here, and then you can go, for those ambiguous words, how does it respond with different variants of that? How does that change the outcome? And we found some really counterintuitive and potentially quite dangerous ways it might interpret things because of the underlying steering of the model that we don't have access to. We don't have access to be able to say, hey, pay attention to this part more. This is what I really mean when I use the word must or unique. It's a minefield, right?
Yep.
And these things have extremely nonlinear outputs compared to some input, and that means you have to characterize it if you were deploying it in a really high stakes environment.
Yeah, something I find very interesting about the models is with ambiguous, like the output of the models is non-deterministic, so it's a little bit random. You might start a chat session or something, get one result, and then another session you might get a different result. And then that paired with ambiguity, you can have some slightly ambiguous words. You might get a certain chain of behavior from one agent and then the next and then the next. But then the next one is like, because they're all kind of fresh, is different. And it's like, oh man, what happened? Like that's so random. But it's like maybe you've got some ambiguity in a prompt or in some like rules somewhere. And it's just chosen to interpret it different.
Yeah. I don't know if you've seen the tree of thought algorithm, but essentially what they did was you do n rolls of the dice. So you run the same prompt, let's say 16 times, and then you, kind of like chain of thought, but what you do is you've got these 16 results, you put them all into the same prompt, and then you say synthesize a better response. And they measured a significant uptick in the output there, which is interesting, right? The question is what should n be? Should it be 16? Should it be 100? Should it be how much? What's the economic value of doing that? Of doing that, because in the end it's gonna cost a lot of money. It's like the labs are building these algorithms to try and maximize token usage, right? So
Yeah. And there's about the ambiguity in the words. I know Anthropic does this. I'm sure other labs do it too. But there's almost what you might call word hacking, where they whatever they're doing with their constitution or SolMD file that they use during training, they specifically use very niche, not frequently used words in there to activate certain parts of the model, because all of the words that it learns right, almost like the normal distribution of how these are used in relation to other text. And by hitting, very niche cases of that have very specific meanings, they can steer the output more directly, which I think is very interesting. And so I think that's probably also a skill, right? If you're putting the right detail and using the right words in the right context, I think is very powerful and all that stuff. And and all the roles of N, I think there's that you can go on forever, and that's kind of what Google did with Alpha Evolve. I think is they had a Gemini model, which looking back is nowhere near the top performance level was Gemini 2.5 or something. But because they're Google and they just it was DeepMind, so they just had kind of unlimited runs, and they just put it at certain problems, and were all right, you need to improve the multiplying a 4x4 matrix. And so before I forget what the number of multiplications was, but this is something that's been optimized over decades right, by the top like scientists, because there's that's how models run in a lot of compute now. It's just matrix multiplication. So any single operation you can shave off there is like millions or billions of dollars, right, of compute. And they just kept running it and improving it, and it ended up shaving one operation off and finding something new that no one had thought about, just because they rolled the dice enough times, right?
It's amazing.
So it's very, very interesting, right? What you can do when you just keep going, keep re-rolling.
Now, early on when we were doing a lot of experiments in attention and sort of using open source models and then looking at the attention matrix and so on, we started looking at, we were trying to prevent it from doing certain things just with prompt engineering. And we would use the words, do not do X, do not do this, you must not, blah, blah, blah. You see these quite a lot in prompting. And what we found in our use cases, not saying it applies to everyone, was that when you flipped it to a positive wording about what you should do, not what you shouldn't, that we had much lower rates of hallucination. I will anthropomorphize, even though I shouldn't, because if you ask a person, let's say there's a really interesting one where Darren Brown, the mentalist, he was on a show and he had the world's best tightrope walker who'd never fallen, and he said a few words to him, which was "don't fall." And the guy's up there, and he fell for the first time in his life. Yeah. And I do wonder whether that sort of age-old wisdom of don't never say the negative aspect of it, always keep it positive, is like it's so imbued in the training data of these models that by saying don't do X, you actually increase the probability of it somewhat on some edge case. Yeah. So I don't know if that's true, but that's what we found.
I'm sure it is. There's also a paper I saw recently from Google where they found that the performance of the model goes up if you just put in the prompt twice, because of the way the attention mechanism works. Because if you define something and then talk about it later, the second time you define it, the description of the thing is used in attention to like relate to it. So it's like there's actually a difference in how the model, I guess, internally thinks about something and reasons about it and how it affects the output based on where in the prompt it appears and if it appears again. Because it like allows it to form a stronger connection to that thing. So it's like there's so much of that stuff. It goes so deep, and it's it's really interesting.
There's a couple interesting things where like if you say don't do something, maybe that part of text goes into attention. The other one is the solution space of do this is quite different to the solution space of don't do this, because if you're saying do this, maybe you end up with like this many results. And if you say don't do this, well, it's actually infinity minus this much.
And also the don't is only it has to, the attention matrix has to relate the don't to the thing that you're asking it not to do, and that may or may not be interpreted. We don't know. We don't have the access to that part of the architecture. Things like where I found reading Claude's system prompt, or the leaked one at least, I don't know if it's real, quite interesting, because they'll repeat things multiple times, one sentence multiple times throughout the system prompt. That's an interesting technique. They introduced the word ultrathink, and for the same reason that you had before, is that ultrathink doesn't appear in human language. So obviously the model will pay high attention to it because what the hell's this? So ultrathink, this particular topic will maybe increase your result.
That was going to be my last question, is what do you guys think the normal distribution of usage of the word ultrathink is? English literature?
Yeah. And how models evolve, because how humans talk shifts, right? And like slang, and especially like people, what we say in, like
the load bearing thing?
Yeah, like how if people, I guess probably as younger people as well, especially, more with social media and stuff, as trends, flow and rise and fall, how the way they talk and about things and describe things changes, and how that changes to, when the models are trained with their training data. Like, would I be worse at prompting a model that was now 2 years old because it was trained on how people talked at that time, and because it's changed and there's like new concepts and stuff like skills and stuff that it might not even know about, because it has like that wasn't a concept back then.
Yeah, and the meaning of a word completely changes.
Yeah,
like between 1950 and now. I don't know if you saw there's some guys who trained a model on the pre-1950 kind of or pre-1990 kind of data. No. It was like all on the old books and everything. I haven't used it, but I mean, it's interesting, right? Yeah. Because it would interpret many, many words very differently than we would interpret them today.
Yeah, it's like crazy what OpenAI is doing with their the reasoning. Like now the way they've made these models more efficient now, like the latest generations are like now much more efficient than the Anthropic ones, just from like cost to like tasks done. And what they've been doing is I don't know if they've officially confirmed it, but sometimes it leaks into like things because these models aren't perfect, and it's like grug speak is what people are calling it, because it basically like they've trained it so that the reasoning happens in only the important words and they take out all the fillers. So it's like caveman talk. It's like me go think this thing now.
Or maybe what secretaries were trained to do back a long time ago, where they had that shorthand, right? And people literally learned these, highly efficient ways of encoding what executives say, right? So maybe it's there. I don't know.
Yeah, no, it's really interesting.
Or it could just be Vulcan, right?
maybe. Oh, I think we probably wrap it up. It's been a long episode, but a really great one. So much interesting stuff discussed. We've gone like all over the place with the. It'll be interesting what the response is.
How do you cut this up?
Yeah. No, but it's been great, and I've really appreciated, especially from you, Joe, some of the like really articulate descriptions and reasoning about some of these really complex problems and stuff that like I don't think a lot of people would be able to describe like that just on the spot and like this. It's very, very impressive, very cool. Yeah, so thank you very much.
That's been awesome.
Making the
really
time.
enjoyed it.